Hello. So what we're going to do in this video is we're going to go through all the series tests and when we might want to use those series tests. Okay, so the first thing you need to understand is you need to understand geometric series and p-series. A geometric series is a series sum. You have some constant times some constant to the nth power, and these converge when absolute value of r is strictly less than 1. And moreover, we know precisely what it converges to. We know it precisely converges to the first term in the series over 1 minus the ratio. Okay, so they're special in that regard that we know when they converge and we know what they converge to. We also know when they diverge. Geometric series will diverge when the absolute value of r is bigger than or equal to 1. Okay, so that takes care of geometric series. You should also be aware of p-series. So a p-series, we'll put in green. P-series is one where you have the sum over 1 over n to the p. Okay, and these converge when p is strictly bigger than 1. And they're going to diverge when p is less than 1. Actually, I messed up earlier. P-series do not converge when p is equal to 1. When p equals 1, you get the harmonic series. So those actually diverge. Okay, so the second test, and probably the most, so if you don't have a geometric series or a p-series, probably the next thing you want to think about is using a ratio test. You want to use ratio tests when you see things like factorials. Those are those things with the exclamation points. When you have exponentials, exponential functions, uh, and what I call mixed functions. That's where you have an exponential and a polynomial, an exponential, a factorial, something like that. You probably want to use ratio test. Okay. For ratio test, you take the limit as n goes to infinity of the absolute value of the n plus first term in the series over the nth term. And if this is strictly less than 1, it converges. If it's bigger than 1, it diverges. And if it's equal to 1, it's inconclusive. Okay, so if it's less than 1, it converges. If it's bigger than 1, it diverges. And if it's equal to 1, it's inconclusive. Okay, so the next test is the limit comparison test or the comparison test. So you usually want to think about using limit comparison tests when you have a rational function. Okay, that means you have a polynomial divided by another polynomial. Okay, so when you have a polynomial divided by another polynomial, you want to compare it to either a p-series or a geometric series. Okay, and we'll go through an example of this a little bit later on. And with limit comparison test, you take the limit as n goes to infinity of the series you are interested in, divided by the series you know, because it's a geometric series or a p-series. And if this is a number, a positive finite number, they both do the same thing. So that means if the P series diverges, the series you're interested in also diverges, but if it converges, the series you're interested in also converges. Okay, so you use the alternating series test when you have -1 to the n, or -1 to the n plus 1 or n minus 1, something like that. So it alternates between positive and negative. If it does that, it converges when two things happen. The first thing is that it must be the absolute value must be decreasing. And the second thing is that the limit of the B sub n's has to be 0. Okay. And that's where you're adding up something that looks like this. Okay, and when do you want to use integral test? You probably don't actually want to use integral test. It's a lot of work. You have to turn it into an improper integral, and you never actually want to use it unless I ask you to. Okay, so that's it for this, and we'll go through a couple of examples here.